Hello, and welcome everyone to today's webinar on Best Practices for Amazon Web Services Redshift. Today's session will focus on reporting and advanced analytics. I'm Greg Kerala, Business Development Manager at Amazon Web Services. Joining me today is Adam Savitsky from Yahoo and Scott Hoover from Looker, who will be participating in today's call to review their case studies. As a quick background, today's session is intended for more advanced users of Amazon Redshift. If you're new to the platform, we did record a Getting Started webinar series back in June that you can link to from YouTube, or you can go to YouTube and search for Getting Started with Amazon Redshift for the date back in June. Also this week, we've been going through a three-part series in terms of best practices. On Tuesday, we talked about optimizing Redshift performance. Yesterday, we discussed best practices around migration and data loading. And today, we'll be covering reporting and advanced analytics, and importantly, going through a few use cases of how customers are actually using Redshift today. All three webinars will be posted to YouTube, and from today's webinar, you will receive an email once the recording has been made available. Throughout today's webinar, you'll be able to ask questions through the Q&A window. And at the end, we'll be taking a separate 10 or 15 minutes to address those questions, but feel free to ask throughout the webinar, and we'll try our best to get to your questions as time permits. Also, once we finish up the presentation part before we start the Q&A, we'll be going through a quick survey where we hope to get your feedback to improve future webinars by Amazon and our partners. So in terms of today's agenda, I'm going to quickly cover some information around connecting to Amazon Redshift, and then we'll go through two case studies. We'll get some in-depth explanation of how Yahoo and Looker are actually using Redshift in production environments today. And as I mentioned, we'll have questions and answers at the end, but again, feel free to ask questions throughout today's presentation. So just quickly, even though today is intended for a more advanced session on Amazon Redshift, I just wanted to level set that Amazon Redshift is our managed data warehouse solution that can start as small as a few hundred gigabytes and then potentially grow to many petabytes in scale. And it is a relational data warehouse, so it still has constructs such as tables and schemas, but it's massively parallel to allow crunching of large amounts of data to get back decisions that help grow your business. Also, it's a fully managed platform, meaning that common tasks such as backup, recovery, patching are all provided as part of the service. And we provide two different platforms, one for solid-state drives and one for magnetic drives based on the price, performance, and computational activities that you're doing as part of your analytics. And of course, one of the groundbreaking features of Redshift is the revolutionary pricing that we bring. So, of course, you only pay for what you use. You can grow on demand, and your price could be as low as $1,000 per terabyte per year. So we'll broadly talk about three use cases where we see Redshift used in production environments. The first is augmentations or replacements of traditional data warehouses. So these are companies that have existing on-premise data warehouses that look to migrate to Redshift, either to completely replace an on-premise system or to augment an on-premise system for new workloads, such as Internet of Things or logging type analytics. Their current setup might not allow for those type of activities. The second is companies with big data. So this is, of course, a lot of our customers that want to, leverage the power of a managed data warehouse platform to take into account log analytics or Internet of Things type applications. And the third are software as a service companies that are looking to add analytics to their particular application. And again, more details can be found on AWS at amazon.com/redshift, and look for our customer case studies that highlight these three broad categories. So for connecting to Amazon Redshift, I just wanted to briefly talk about, to finish off our series from the week. So remember, Tuesday was optimizing performance. Wednesday was being able to efficiently load data, and today is focused on reporting and analytics. So from a Redshift perspective, Redshift exposes itself as a Postgres compliant database, meaning that any BI or analytic tool that can talk to a Postgres database can talk to Redshift, and it is fully ANSI SQL compliant. Now, to help with performance, we did release custom ODBC and JDBC drivers that can be downloaded from the Redshift console. We are seeing anywhere up to 35% higher performance versus open source drivers with some optimizations we put into our drivers. Of course, we will continue to support the open source Postgres drivers as well to provide that level of assurance for any kind of customers that are looking to use the Postgres drivers. But generally, we find better performance by looking at our custom ODBC and JDBC drivers that you can download from the console itself. So that might sound fairly simple from a reporting perspective, but we wanted to provide a little bit of insight in terms of the breadth and depth of partners that I can actually work with Redshift. So here you can see a broad range of consulting partners that help you with implementations of your Redshift projects, as well as third-party tools for extract, transform, and load and business intelligence that natively work and have been optimized for the Redshift environment. So having gone over that quick overview of some of the basics of Redshift and the ability to connect through ODBC or JDBC tools that know Postgres databases, we then wanted to go through a couple of use cases to actually understand how advanced analytics are implemented and provide that insight to ask questions to as well. So I'd like to turn it over to Adam from Yahoo to go through how Yahoo is leveraging this platform for their cohort analysis. Adam, the floor is yours.
My name is Adam Savitsky, and I'm here to talk to you today about how we're using Redshift for analytics at Yahoo. So I am a member of the Yahoo growth team. We have 6 different products that we're currently supporting. We're planning on adding more. I guess the images aren't showing up here for some reason, but I think Yahoo Mail, Yahoo Flickr, Yahoo Fantasy Sports, Yahoo homepage, those are all different mobile products that we're currently supporting. So in the past, I worked at a startup called MessageMe, where we used Redshift for our analytics, and that was sort of my introduction to it there. And then before that, I worked at a company called Foreo, where I was working on modeling and simulations and stuff like that. So what exactly do we do here, and how do we end up using Redshift at Yahoo? So the state of analytics when I first joined Yahoo was we have a truly enormous Hadoop cluster. I can't tell you how many nodes it is, but all of the data from all Yahoo properties, web and mobile, all get logged to a Hadoop cluster. Yahoo's been a big supporter of Hadoop for a long time, and that's something that we wanted to continue investing in. But at the same time, we didn't have any really great solutions for doing deep dive sort of ad hoc analysis. We had a lot of data, but we didn't have a great way to use it. Sort of the state of the art was really just to run Hive queries, and it would take you maybe 10 or 15 tries to formulate your query properly, and each time you had to run it. And Hadoop is good for large data sizes, but it wasn't the fastest solution, at least not with Hive. So we decided that we were going to take the initiative to build a fast, real-time analytics and reporting solution for a small subset of the data, which is still quite large, but out of the total data, mobile data at Yahoo is smaller than, significantly smaller than the whole. So what sorts of things do we care about? Well, we want product teams to be able to understand how people are using their apps. What sort of engagement metrics are we driving? Sort of how and which user demographics are using the different products. We wanted to do things like run experiments, A/B tests on different features, as well as funnel analysis. For example, new user experience is generally where people want to look at funnels of how people are flowing through the steps of a new user. And then we wanted to do some more advanced kind of stuff where we can model customer lifetime value and revenue. So for our more established products that do have revenue, we want to be able to run ad campaigns at an effective cost per install, and understanding and being able to predict how much revenue a user will produce over time allows you to do that in an ROI positive way. And then finally, the case that I wanted to go over today was cohort analysis and user retention analysis. So being able to understand out of a given set of users, how do they use the product, how do they behave different from other cohorts of users, and how long do they stick around. So I guess, again, the pictures didn't come through on this, but that's okay. The titles are here. So at a high level, we have an SDK that we install in our mobile apps, which sends event data from mobile apps to Hadoop. We then extract them from Hadoop, transform them, stick them in Amazon S3, and then pipe them into Redshift using an ETL tool called Airflow. And Airflow it's an open source tool. It's developed at Airbnb. And then finally, the last piece in the puzzle is we use Looker to then query the data. So on an average day, we process on the order of 1 billion events from about 25 million devices. And then we have key value pairs, so parameters that come along with the events are roughly double the amount of events. We're currently running 21 of the DC1 8x large nodes. They are the most expensive per terabyte, but they're also by far the fastest. At our scale, we're able to do really, really fast queries for pretty much anything we'd want to do. So our data size is quite large. It's not extremely large, but it's big enough that you really need to think about performance and how do you get the most out of Redshift for the types of queries that we want to run. So our data model, the first thing I should say is that we do have to do a number of optimizations to get the best performance. We heavily summarize data. So for example, we do collect every single event that comes from a device, but we can't retain that data for very long. We currently store raw events for about 90 days. But when we do add the raw events, essentially every hour and every day, we roll those up to hourly and daily tables. So for example, in a daily table, you would look at, for any individual user for any given product, for any given event, how many times did they perform that event? And if they performed it 100 times during the course of the day, that would get squashed down to one record. So you can get pretty good compression that way. Sort keys and partitioning are very important. We went through a lot of iteration here, and there are other webinars that talk about that kind of stuff. Data encoding as well. But these things really do help. So our schema consists of a set of raw tables. So each product has their own table with just raw events. These are straight from the device, basically. And then we parse out parameters that come in the form of JSON. Parsing JSON in Redshift is tedious and slow. So we kind of pull out the parameter key value pairs from the JSON ahead of time. So we have raw tables for events, raw tables for params. And then where we do most of our querying, most of our analysis ends up being in summary tables. Because for the most part, you don't need down to the second resolution for events. Usually a daily resolution is good enough. There are some situations in which we would want hourly resolution. But I talked a little bit about how we do those roll-ups. We also import revenue data on a daily basis and telemetry data, which is essentially monitoring performance. Then on top of that, we have a number of what we call derived tables, which we use our ETL tool to build based on raw data or summarized data. So for example, out of the daily event table, we build an install table, and that just keeps a record of the first time we saw every device. User retention, I'll get into that in a little bit. These are all just different tables that support different kinds of analysis. It ends up being a lot faster to do this as part of your ETL rather than building these tables on the fly, especially for the kind of volume that we're working with. So I wanted to talk a little bit about user retention analysis. So I wanted to start with a couple definitions in case you're either unfamiliar with this or maybe use different definitions. We define a cohort as a group of product users that share one or more attribute. It's usually time-based. So we go by an install date, essentially. So if somebody installed on Monday and they had an Android device, that would be one cohort. You could split it out into multiple dimensions. I think we have probably 12 different dimensions, so you can get down as granular as zip code, If you want to, if for whatever reason you wanted to look at zip code level data, you could do that. And then retention is given a cohort that installs on any particular day, how many of them continue to use the product over time. So if 100 users in the Android cohort installed on Monday, and 7 days later 50% of those users were still using it, you'd say the 7-day retention is 50%. So why study user retention? Basically, it's a really good measure of the quality of your product or how sticky it is. If users are sticking around over a long period of time, then that's a pretty good indicator that you built something engaging. You'll see a lot of times you'll have really, really low user retention, and we want product teams to try and understand why that's happening so that they can build a product that best suits the user. And then the other thing is, for more established products that are already generating revenue, I mentioned this earlier, but we want to be able to understand what the lifetime value of a customer is. And user retention is a big piece of that. If the average user is retained for a week and you earn $1 per user per day, then you're going to earn essentially $7 per user over the lifetime of the user. So you could spend up to $7 to acquire that user. So here are two different examples of retention curves, as we would call them. The x-axis represents time, and the y-axis represents the percentage of users that are retained. The yellow curve is what you want. You're never going to get 100% retention, but if you can see that curve kind of level off, then you have found the core users who are going to use your app for a long, long time. Whereas the blue curve eventually goes to 0. So every single user that you acquire, they eventually disappear, stop using your product. Over time, what happens is those users add up. And if you're able to get asymptotic retention, then every cohort of users that's acquired, they add to your total user count. If you don't have that, then you're constantly churning users out, and it's really hard to build up a large network of users using your products. That's more important for some products than others, like social networking, for example, which is heavily dependent on network effects. You want to keep high retention, and companies like Facebook have very, very high retention. It's one of the things they focus on. So this is the kind of analysis that we wanted to be able to provide here, so that Yahoo's mobile products can kind of leverage these strategies. So how do we actually calculate user retention? Well, basically what we do is for every combination of cohort dimensions that we see for every day, we calculate how many users belong to that cohort, and then for each day, how many users from that cohort were active. So this is an example showing like a simplistic example with one dimension just for operating system, Android and iOS. And these are users who installed Yahoo Mail on Monday. So given that they installed on Monday, for any event date that's also Monday, your active user count will be the same as the cohort size, which for Android was 100. 1 day later, we saw 83 different devices from that cohort. So effectively, you could say the 1 day retention for Android was 83%. And then you can do the same thing for iOS as well. And then that's effectively how it all works. We have some SQL that lives inside Looker that does these calculations, these aggregations for active users and cohort size. Yeah, this is the same example. We're just looking at 1 day retention, but this time across both Android and iOS. So what you would effectively do is you would find all of the rows that correspond to 1 day retention, which are these two. And then we would sum up the cohort size for both of those cohorts and sum up the active user count. And we effectively get 145 out of 175, which is 83% 1 day retention across operating systems. So you can see how this could extend so you can kind of build these cohorts dynamically. We wanted it to be really flexible, so you could include one cohort. Like if I wanted to look at, if let's say we have another dimension country, like I could look at one country, I could look at 2 countries, I could look at all countries. It doesn't matter. So how do we get there? So basically for every day, we go and figure out whether or not a device was active. So the first column here is device ID. And this is a simplistic example with 2 devices and 2 dates. But a 1 represents activity, a 0 represents no activity. So once we have that, we join device attributes. And that comes from our install table, the one that I mentioned earlier, that keeps a record of the first time we saw every user. Based on their device ID, we can join records from that install table to this. So we know that this device was active on this date, and they installed on January 1st, and they were using iOS. So the third step is then to take that isActive column and sum it up, grouping by basically any of the cohort dimensions and install date. So you can see here we have this is the column we're summing, isActive. And we roll it up, so we had 2 active users on January 1st and 1 on the 2nd for this particular cohort for this particular install date. Then finally, what we do is we then calculate the size of each cohort. Again, using the install table, we join the cohort sizes to what we did in the prior step. So that's effectively how you get the active user count and the cohort size. So I wanted to show you just a very, very brief demo with the time I have available actually using Looker. So I can, let's see. I'm going to share my screen. So this is Looker. Scott's going to talk about it later, so I won't get into all the details of how Looker works. But this is what our view looks like if you wanted to just do some exploration around user retention. So we have a couple different measures defined. We have an active users count, a cohort size, and a percentage retention. So the first thing I'm going to do is I'm going to apply a filter to product. And I'm going to choose a product by its code name, and I'm going to say dog food, which represents that it's internal testing. So this is an internal app. We're not looking at real data, but rest assured we could look at any of Yahoo's mobile products if we wanted to. So now that I've chosen a product, I'm going to choose days since install, and I'm going to pivot by install date. And then I'm just going to put a little filter on here that says install dates in the past 2 weeks. The past 14 days, what was my user retention? And this is across all users. We're not breaking it out by dimension at all. So this is going to run. It took only 5.6 seconds. And let's see. I'm going to just sort it a little bit. And then you can see, okay, for the cohort that installed on July 10th, as of, let's see, hold on. Yeah, so as of a few days later, there were 50 users who installed, and as of, I guess however many days that is, there were 3 users remaining, or 6%. So let's look at just one install date, because I'm going to add some more. So on the day 7/10, let's go back to there. And then I'm not going to, let's see. Yeah, so let's break it out by operating system. So if I pivot by OS, now we should see for iOS and Android what our retention was for that one particular day. And you can see, okay, this is how it breaks down. 36 users were on iOS, 14 were on Android, and then over the next several days, how that all shaped up. You're not limited to doing that. Like, you could filter by just gender if you wanted to. We can look at pretty much anything, like device type, device OS version, device make, model. It's really pretty flexible and fast in terms of what you can do. So this is just males now. You can see how that breaks down. Anyway, that is all the time I have for the demo. I guess I can show you the SQL real quickly that gets generated. Looker generates all this for you, and it all just comes from that user retention table, which gets built the way I described. So let's see if I can get out of my sharing. And then I have one more slide. So yeah, I just wanted to talk a little bit about what the lessons are that we've learned. The big one was you should always summarize data, at least hourly. Daily is better. The reason is it's an order of magnitude difference on query performance versus querying against raw data. And then you really should think carefully about the data model you want to use. Choose the right sort keys. Build the right derived tables based on the kinds of analysis that you want to build, because that's really going to help you. Invest in a good tool for ETL. Like I mentioned, we used Airflow. We're pretty happy with it. For anything that touches Hadoop, we use Uzi. That's okay too, but I think Airflow is better if you can use that. I think it does have connectors for Hive. Invest in a good tool for query building and sharing. We use Looker. Like a fast database is only half the battle. A lot of times what happens is somebody will they'll do a whole bunch of analysis. They'll have a big complicated SQL query and tables that they've built and everything, and views and this and that. But if you can't really share the results in a repeatable and dependable way, then it's not that useful for you. And then you're going to need lots of spare capacity. If you're doing any kind of non-trivial ETL, it uses up disk space when it's running. The disk space is eventually freed, but you don't want to run out while you're doing your ETL. At least if you're doing anything that's going to exhaust the memory like we do. Like building that table of for every user, are they active on any given day? That takes a lot of memory, and it ends up spilling to disk, which is fine. We're doing it as part of ETL so that users don't have to experience it, but you do need spare capacity. And get reserved nodes if you can. Save a lot of money that way. On-demand pricing is expensive. If you can in any way get commitment to use reserved nodes, even if it's just for a year, it's much, much, much cheaper. And then I think I alluded to this earlier, but the dense compute nodes are a lot faster, but they do have smaller capacity, so there's a trade-off there. We did try the new dense storage types, the ones that just came out that have improved disk I/O and more memory. They were okay, but we did notice performance impacts. Our ETL took longer, and some of our queries took longer too. Mostly it was a problem with the ETL. I think it just didn't quite have enough memory for what we were doing.
Thanks, Adam. Good morning, everyone. My name is Scott Hoover. I'm a data scientist here at Looker, and I'm going to talk a little bit about how we're actually using Redshift internally, and then just provide a couple of use cases about how some of our customers are using Redshift. And I'm actually going to focus on a couple of atypical use cases, which I think are particularly interesting. First, just a brief introduction. We use Redshift internally to power our own implementation of Looker, and it serves basically every department with business intelligence and data for subsequent analytics. Everyone from marketing to product to customer success to finance, everyone is in Looker, kind of self-serving their own BI, and all of this is driven by a Redshift cluster. We actually use dense compute, and we have a 4-node cluster at present. About myself, I've worked at Looker for just over 2 years. I've done quite a lot of things, from sales engineering to professional services and implementation to data engineering, and I'm currently heading up internal analytics efforts. I kind of went over my agenda. Really, I just want to give a case study into how we're using Redshift at Looker, and then just a couple of case studies on our two customers. So our decision to go with Redshift was really kind of driven by 2 major use cases. The first was the requirement of doing fast analysis against an increasingly large usage, like app usage event data set. Before our migration to Redshift, we were doing analysis against our event data on on a small MySQL database, and we were really beginning to sort of tax the analytical capabilities of this database. Redshift was sort of the obvious choice when it came to performance. The second was to really centralize multiple data sources into a single data warehouse, and while there are many data warehouse options, the requirement for speed and also the cost consideration kind of made Redshift a no-brainer for us. I want to just talk briefly about some of the metrics that we care most about as a SaaS company. There are really kind of three overarching aspects of the metrics that we look at regularly. The first of which is customer health. This is absolutely essential to us. We have a huge number of metrics that go into assessing customer health, and I've just provided kind of a handful of them. Generally, we kind of look at things like, what does month over month or week over week percent change in usage look like, both at the user level and the client level. Are our clients adding or removing users? What does user engagement look like? So, at a given customer, is it dominated by developers, people who build out a data model and kind of write LookML, also build dashboards and sort of build queries? Is it dominated by people who just explore data, so kind of analysts and inquisitive business users who go in and poke around and just do data exploration? Are there a lot of consumers there, people who really don't build their own queries, but consume a lot of dashboards, get scheduled reports, and kind of jump into Looker? Or are we talking about like occasional consumers, people who kind of come in and view a dashboard and then cut out? Lastly, we look at the maintenance of the model, of the data model. So are people contributing in a kind of a deep way? Like, are they writing a lot of LookML? Are they sort of minor changes to their model? And what is the blend of contributors of the data model? That is everyone at the company, both a developer and a consumer, or does it skew the other direction? That is, it's really the model is maintained by one or two people, and everyone else is sort of a business user. On the product usage front, we'd like to understand, which features are used and which are not used. As we introduce new features, we like to get a feel of, what's important to people, what's not important to people, and how we can improve upon these things. We have a pretty aggressive release cycle, so we come up with a new release every 4 weeks. And it's important for us to understand which releases and which features, cause friction. Did we change the way that persistent derived tables are managed within Looker, yielding, some pain points for developers? This is something that's really important for us to understand. GitHub usage and feature tracking. So we get a lot of feedback from customers and a lot of feedback from our customer success team, and it's important for us to monitor all of this information. And then lastly, reporting for sales and marketing. So these are your sort of bread and butter metrics for the business. What does usage look like in trial? And can I like reasonably predict that a prospect is interested in actually going with Looker? Across all teams, what does performance look like relative to some quota? So are we meeting sales targets, meetings targets? Do we have a sufficient number of leads? This sort of thing. What do things look like on the lead or prospect fit kind of realm? That is, as we see users come in at the top of the funnel, what sort of behavior are we seeing from people, and what sort of customer fit can we kind of glean from our data? We do some interesting stuff with campaign attribution. We have 3 ways of actually analyzing the impact of our marketing campaigns on our prospects becoming customers. And then lastly, some sort of standard SaaS metrics: MRR, CMRR, churn, revenue at risk, that sort of thing. I wanted to talk briefly about our data pipeline. The left-hand side sort of shows us all of the data sources. Actually, this is not an exhaustive list, but these are really the essentials. The list of data sources and how they all flow up into Redshift. So we use Marketo on the marketing side, Zendesk to drive our our chat support, both of which have native connectors into Salesforce. And we migrate our Salesforce data and Marketo and Zendesk into Redshift by way of an ETL tool called Fivetran. It's very cool. We have custom scripts that hit the that hit GitHub and Discourse, as well as our license server, which basically executes periodic checks on number of users and that sort of thing for our instances out there in Looker land. And these are all moved into RDS instances, which eventually flow upstream into our Redshift cluster. And everything there is just custom scripting. Lastly, some event data. And we have our legacy system, and we're in the process of really migrating to Snowplow. Both of these have a very similar kind of data pipeline flow. We have unstructured data. It eventually makes its way into an elastic MapReduce cluster where every couple of hours this data is turned into structured format, piped into S3, and then copy statements bring it into Redshift. For our legacy system, we do that data transformation using Spark. And for Snowplow, it's a combination of Hive and Pig in order to get it into a nice structured form that plays well with Redshift. Looker basically is pointed at this Redshift cluster for everyone to do sort of analytical query writing and historical analysis. I'll also mention that the same Looker instance is pointed at real-time RDS instances for operational purposes. So if our sales development team needs to understand, what their meetings look like today, right now, they have dashboards that really point to real-time databases for that sort of thing. I want to talk about our data model. So really, we have our event data and then everything else. And if I were to sort of capture what our event data looks like in a kind of unstructured JSON format, it might look like this. We have two events, two event types. The first is a viewing of a connection. So this is someone going to the Looker admin panel and saying, what are the connections that I have available to me. The second being a saving of a look or a report. Both of these events have a timestamp associated with them. And then there's this attributes object where we start just stuffing in a variable number of attributes and a different configuration of attributes depending on the event type. So you can see for the viewing of a connection, we have the country, state, browser, and URI, whereas for the saving of a look, we have the country, state, browser, and look ID. The objective from a sort of data model standpoint is to turn this into a very flat, easy to query schema in Redshift. So our Spark or Hive job basically takes that this unstructured data with a variable number of attributes and really spits out a really wide table. We have one row per event. We have a column indicating what type of event we're talking about. And then we have this large number of columns like created at the country, the state, the URI, browser, and so forth, telling us more about that event. Because not every event is associated with every attribute, we get something of something kind of akin to a sparse matrix. So there may be a whole lot of nulls in the error column because that attribute is not filled in for most event types. That's okay. We can make use of column compression in Redshift. Which really kind of reduces the size of this table and really makes it very efficient to query and very fast to query. On the performance note, I'll also mention that we make use of interleave sort keys on this table, which is a relatively new feature that AWS introduced. This is very useful when you have a sufficiently large table, something like 100 million rows or larger, and you frequently filter on multiple columns, sometimes in different scenarios, sometimes at the same time. So for our event data, we're always looking at, the past 7 days, the past 30 days. We're typically using a time filter, but we may also want to do filtering on the event type. We don't want to just take a look at everything. We want to see saved looks over time. This is a really good candidate for interleaved sort keys. Adam mentioned this, but it's definitely important to, particularly when you're working with rather large data in a Redshift cluster, to optimize on the sort key front, which is absolutely essential. And then, provided that you have joins in the mix, being very, conscious about the distribution keys that you go with, or choosing an even distribution style. All right, so that's our event schema. In Looker, 25 lines approximately of LookML provides the user this kind of experience where they can view everything from event or session analysis and map that to that they need. So they can do funnel analysis, they can do campaign attribution, all that sort of interesting stuff in one place. So they get the ability to kind of, you could use Looker's features, explore and visualize. On the left we can see, you can easily visualize distributions. On the right-hand side, you can see, you can kind of view web traffic flow, so where people go from a starting page. Kind of where they end. We can kind of do analysis of, which campaigns and campaign types are touching our customers or rather our prospects at different parts of the sort of sales process. And then we can just do kind of ad hoc exploration. So the bottom right image is actually kind of one of my favorite analyses that our customer success analysts have devised recently. And it's really a Salesforce data validator. It's really interesting. So if there are ever any sort of anachronistic events in a particular Salesforce object or an account, this checks for sort of common errors and missing data. So something that's really important to us is actually maintaining cleanliness of our human input data. I wanted to talk about a sort of more advanced topic and how we use Redshift to actually kind of drive some of our lead scoring efforts. So this is kind of a new endeavor for us. So, in Redshift, because we have our event data and we have all of our, our other kind of ancillary sources, our Salesforce, our Marketo, our GitHub information, we get this really kind of high-dimensional view of our prospects and of our customers. And one thing we can do is, ask questions about lead fit. And so what I can do, so I'll kind of walk you through the steps here. So in Redshift, I have my high-dimensional data set. In Looker, I'm going to build just a basic report that grabs some, some key attributes that I think might be good predictors of lead fit. Within Looker, I can kind of do all the data cleaning and the data munging and just have this nice clean report, which I can then pull from the Looker API. I can basically get my look or get my saved report and pipe it into my preferred sort of analytical language, so Python or R, as I'm using in this example. I can build some predictive models. So if I want to use like a logistic regression or naive Bayes to kind of determine, which predictors are, useful in kind of determining lead fit, and then kind of spit out a, likelihood of, let's say, taking a meeting or something like that, I can kind of build my model, tinker with it, and get it dialed in, and then use this this file type called PMML, which is a predictive model markup language, which is basically an XML file. But it's really handy. What it does is it captures all of these sort of model parameters or coefficients. It contains a data dictionary. So if you have like a categorical variable, what the sort of values you might expect to see for incoming rows for predictive purposes, and then how to treat outliers or missing values and that sort of thing. So there's this kind of Java API called JPMML, which actually does something interesting with these PMML files. OpenScoring.io has some interesting distribution of JPMML to kind of utilize this in different ways. You can kind of deploy this RESTful API on Heroku or on an EC2 instance, as I have demonstrated here. So basically, we have a server which is hosting this little API. And all I need to do is write an application that hits the Salesforce API and gets new leads as marketing updates lists or add lists to Salesforce, or as people submit forms on the website. This application gets new leads, sends it to the scoring API. Basically, probability is spit out for any given lead or a batch of leads. And then my application then updates the lead record up in the Salesforce API. The interesting thing is that this is sort of a closed loop. So, ultimately this information flows back up into Redshift or a RDS instance for, kind of real-time analysis, giving sales and marketing sort of lists of leads that are kind of important to follow up on. So you can kind of do prioritization in the event that you have a large number of kind of people to filter through. I'm going to skip this slide in the interest of time, but basically here's some reasons why our customers chose Redshift, and this really mirrors our own decision to go with Redshift. So I really wanted to focus on two kind of atypical use cases of Redshift that I've encountered out there. We have a lot of customers that use Redshift. The big kind of overarching theme is that they have sort of taxed their transactional database when it comes to analytical query writing. And they need to do, event analysis in something that can really handle scale and scale well the company. And so that's the most common use case we hear. Here are a couple of sort of atypical cases. So we have a customer Backstage/Sonic Bids, and really what they are is a marketplace for talent. Unlike Simply Hired or Upwork, they focus on artistic talent. So booking agents and artistic directors, let's see here, casting directors, they can go into Backstage and Sonic Bids and sort of find talent for a particular project, show, movie, production, what have you. Something that they did recently was kind of rebuild their artist search engine. Something that I think they did that was interesting was actually scrape social data. So for each artist, they go out there and kind of find, YouTube plays, information on Twitter, Facebook, and SoundCloud, and then using Snowplow, pipe this information into Redshift. They have a data model that kind of summarizes this information geographically, at the artist level, at many different levels, all done in Looker. Then they use the Looker API to basically sort of populate this information into an Elasticsearch engine, which really drives, into Elasticsearch, which drives their sort of artist search tool that they've constructed. Something that I really like is that they have these indicators of social metrics, which gives talent seekers some sort of interesting indication of potential draw for, say, a band in the region. Or the popularity of a given actor or something along those lines. Pretty interesting and unusual use case. The last one I want to talk about is a customer called SmartLink, and really what they do is translate websites basically into all sorts of different languages, and they have many actually interesting use cases for Redshift. One of which is the storing of sort of snippets of translated snippets. So, for instance, if historically they had a request for "the car is red" in Turkish, this is information that they store in a database, and they have a sort of fuzzy matching algorithm. I think it also makes use of naive Bayes, so that when a similar request comes in, so something like "the car is blue" in Turkish, they can use this fuzzy matching and kind of reasonably determine that the translation for "the car is blue" is syntactically valid. It's similar to something that they've seen before, and they can use this to speed up the velocity of their translations, as well as sort of kind of rank translator accuracy, which I think is really interesting. That's about it for my time. I'll mention that we have a large number of interesting use cases of our customers using Looker on top of Redshift at our website. So I encourage you to kind of visit www.looker.com to learn more. And with that, I will pass it back to Greg.
Great. Thanks, Scott. Hopefully everyone on the call today was able to get some value by listening to these two great use cases. And I wanted to provide a few minutes to get your feedback on how satisfied you are with today's webinar. So in the meantime, while we're asking you to fill out a few short questions about your satisfaction with today, if you could also queue up some more questions, and then once we finish the survey, we'll ask Adam and Scott to come back on the line to address your questions over the line. Great, so let's give it another few seconds for the survey. And then while we're completing the survey, if I could, just in terms of an order, if we could have Adam answer some questions first, and once Adam has answered a few, we'll then have Scott answer a few questions, and we have about 10 minutes or so for Q&A, and any questions we do not get the chance to answer, we'll try to follow up directly. But Adam, if you'd like to take some questions.
I've got one question here from Russia Madden. He's wondering, what are the use cases for persistent derived tables? Performance-wise, this could be expensive as far as users processing large queries. Yeah, so that's a good point. Generally, we use persistent derived tables in any situation where we have some sort of, the table you're querying against isn't just a table that you have in Redshift. It's effectively a view that you want to materialize. Redshift doesn't have materialized views, but it's a handy little feature from Looker that allows you to effectively materialize a view. Now, you would really only do this if you have some sort of view that you need to run a query against, but that view is expensive enough to build that you wouldn't want to run it every time somebody wants to look at that view. So effectively, you're materializing that view. Now, if it's really slow, that's the kind of thing that you would want to take and you would want to put it in your ETL process. But for simple things, like stuff that maybe takes 5 minutes to run, and then after that you can cache the table, that's a good use case for a persistent derived table. One other problem we noticed with persistent derived tables is the way they're generated is they use create table as, And that's all well and good, but when you do that, you don't actually preserve any of, well, you don't get any column encoding at all. So effectively, your data compression on those derived tables is pretty small. And since they are materialized to the database, they take up space. So if you have a really, really, really big derived table, persistent derived tables are probably not your best bet either. But they do make sense in some situations. Hope that answers your question. Let's see. I have a question from Gaurish Sharma. How does one go about designing the data model schema for a database? Well, you have to kind of understand what the inputs are. Like, we knew that we were going to be getting events from mobile devices, and mobile devices only. Now, we have Hive tables that are already pretty much structured to accept that format of data. So the first step in taking like raw data and importing it was pretty simple. We maintained most of that schema. From there, we had to work with product teams to try and understand the type of analytics that they wanted to run. And once you understand what kind of questions people want to ask, you then think about, okay, how can we design the data to facilitate that? And that sort of led to a process of identifying what derived tables can we build, what summary tables do we need to build, that sort of thing. So that's part of it. And then the other part is really just the fundamentals around selecting good sort keys, thinking about the types of queries that people are going to run frequently, and then designing sort keys around that. So I mean, to give you an example, for us, for pretty much all of our tables, our first sort key is product. The rationale behind that is, well, if somebody's going to come look at events, they're not really ever going to care about looking at more than one product. Like, they want to know how many DAUs were on Yahoo Mail yesterday. So the first thing they're going to do is they're going to filter by product. So by choosing product as the sort key, you effectively filter out most of the other records. The second sort key we chose was event date, because most of the time people are going to be looking at one product, and then for that product they're going to be looking at a specific date range. So the last week, the last 30 days, the last 60 days. So that helps us filter it out again. And then with each sort key you get diminishing returns. Now that's true for traditional sort keys. Interleaved sort keys are a different ballgame. And I'll leave that to you to explore. We haven't used them because I think our sort key system works pretty well actually. But yeah, that's kind of how we thought about it anyway. Let's see, I have a question from Lorgio Jimenez. I hope I'm pronouncing that right. For ETL steps, are you creating custom workflows or using something like the AWS data pipeline? We are creating custom workflows. We're using a tool called Airflow. It was developed at Airbnb. It's open source. The guys who built it used to work at Facebook before that, where they used a tool called Data Swarm, and which is supposedly pretty good. And Airflow is modeled after Data Swarm. It allows you to define directed acyclic graphs in Python for your different steps, and they support all kinds of stuff. They have obviously a Postgres connector, which we use to talk to Redshift. They have Hive connectors, Pig connectors. They have Python operators, so you can run steps in your ETL process that run entirely in Python, which we do. We have a model that runs a regression model that runs in Python using NumPy. So it kind of lets us tie everything together. AWS data pipeline is pretty good, but my basic understanding of it, and I'm not an expert, is that it doesn't give you too much flexibility in terms of data sources and things it can talk to. But for your use case, it might actually be good. Anything within the AWS ecosystem tends to mesh pretty nicely together. So if everything that you want to do is in AWS, you have data in Dynamo, if you have data in RDS, then AWS data pipeline might be a pretty good fit. Pitt Fagan is asking, how does Yahoo handle geographic queries? I believe Redshift does not currently have geographic capabilities. Yeah, that's true. It doesn't, as far as I know. we don't actually store latitude and longitude. We don't have the data, nor are we permitted to store it for privacy reasons. Typically, we don't, in our use cases, we don't really care either. We do tend to query pretty often by country, sometimes by state, or very rarely even city. We can go down as far as zip code, but as far as I know, most people aren't using it. The way we actually get the state, city, country, zip, etc., that comes from the IP address, and that happens as part of batch processing in Hadoop. So we don't have to deal with that. We just get the values. But in terms of latitude and longitude queries and distance calculations and radiuses, we don't deal with that at all. And I don't have a good answer for how you would go about doing it. I have done stuff like this before using Postgres without using PostGIS or anything like that. And effectively, you're writing pretty complicated where clauses, and it's not optimal. I guess that's what you'd have to do with Redshift. All right, I think those are all the questions that were assigned for me. Feel free to ask any more if you have any burning questions. Maybe I'll turn it over to Scott to answer any questions that came in for him.
Great, and we have about just a few minutes for.
All right. I saw one question about migrating NoSQL, data stored in NoSQL or something like Mongo, and getting into Redshift in an efficient manner. And the question was actually already answered, but I am familiar with a tool that actually specializes in Mongo to Redshift, and it's called Illuma, and it's actually quite good at that particular data flow. Let's see here. I got a question which is, how do you use Snowplow there? It's partly open source except for the parsing and processing part. It is in fact open source, and the Snowplow repo has step-by-step instructions for implementing it. There is a service component of Snowplow, so the technology is open source, but kind of custom tailoring and sort of getting custom tracking and collection going. You can figure it out yourself, or you can rely on the Snowplow team to assist with that. So that's one approach to kind of fully implementing Snowplow. There was a question, does Looker provide out-of-the-box time series measures like quarter-to-date and year-to-date or a year ago? The answer is kind of not really. There's no button that you press, but rather Looker makes use of natural language filtering. So if in a query saying like count of events, we can actually apply a date filter, which Adam used in his demo, and besides the drop-down where you choose a calendar, you can actually just type natural language that says, this year, which will give you a year-to-date, or you can say like last year, which will give you all of 2014, that sort of thing. So it's quite flexible. And I think maybe, well, we're over time, so I think that's probably it for me. Greg?
Thanks, Scott. We have time to just assemble a few more questions if people want to put them in the window, and we'll definitely capture your questions and then try to respond as time permits as well. So again, thanks everyone for attending today's webinar. We definitely appreciate your feedback, and thanks to our speakers Adam and Scott for their time today as well. And keep in mind that we will be recording, we had to record this webinar, and we will be providing you a link to the recording, as well as the remainder webinars we have from the previous week in terms of optimizing Redshift performance and data loading will be posted on YouTube shortly. So thanks everyone. Hope everyone has a good day. Thanks.